Hi, welcome back to Mr. Slover's Math. Today we're going to talk about the quotient rule of exponents. So we're going to start off with what we saw yesterday and the day before. We're going to simplify the following expressions. We got 5 squared raised to the 4th power. So because it's a power to power, we multiply those exponents together. 2 times 4 is 8. Our base is 5, so that's why it stays a 5. In letter B, this is just the product. We're doing 3x squared times 2x. So we multiply our coefficients together, 3 times 2. And then the x squared and the x, because they're the same base, we add our powers. Letter C, I have a power to a power again. And keep in mind, this negative 3 has a power of 1. It's really saying negative 3 to the first times b to the 4th. So because it has that power, I still need to multiply it by the 5. So 1 times 5 was 5, and then 4 times 5 is 20. So today we're focusing on this, which is division. So 2 to the 4th over 2 cubed. So if I were to expand this out, I get 2 times 2 times 2 times 2 over 2 times 2 times 2. And now you can reduce. So way back in the day, you learned that if it's the same number in the numerator and same number in the denominator, you can cross those out or they reduce to 1. So 2 over, I can cross that off with that 2 with that 2, that 1 and that 1. I'm left with 1, 2 left. 2 or 2 to the first. So these other 3 are the exact same concept. I list out all of the ones. I'm expanding everything that I have in the numerator and denominator. I'm reducing, and I'm left with 3 as my base to the 4th power. And I do the same thing with variables. So I list everything out. I reduce what I can. I'm left with 4 of them. So I need to think, what can I do? Because these are the same bases. Base is 2, base is 2. I was able to do something over here, and it reduced. Same thing with the 3's and the x's and the 3's and the k's. Because they're the same base, they reduced. So if I look at my exponents, because that's what we're focusing on, what operation could I do with the 4 and the 3 that would give me a 1? Or what operation could I do with the 7 and the 3 that would give me a 4? What operation could I do with the 6 and the 2 that would give me a 4? What operation could I do with the 5 and the 1 or the 5 and the 3 that would give me the 4 and the 2? Hopefully you were thinking subtract. If you do 4 minus 3, you get 1. 7 minus 3, you get 4. 6 minus 2, you get 4. 5 minus 1, 4. 5 minus 3, 2. So when you are dividing 2 powers with the same base, you keep the base. So the base doesn't change, and you just subtract your powers. If there are coefficients, that's the larger printed number, not necessarily the larger number, the larger printed number, you divide your coefficients. So example 1, simplify each expression. So same base, so I subtract 10 minus 4, and I get 6, y to the 6th. Letter B, my base is 5, they both have the same base, so I subtract 8 minus 4, and I get 4. Letter C, they're the same base, so I subtract 3 minus 14. Well, if you look at it, I have x cubed over x to the 14th. I have more x's in the denominator than I do in the numerator. So that means after I do that subtraction or that reduction, I'm still going to have more in the denominator, which is why x to the 11th is going to stay in the denominator. It stays positive. Okay, we'll get more into that in our next lesson. But right now we're just going to look and we're going to see, oh, there's more x's in the bottom. It stays in the bottom. Example 2. Now I'm throwing in coefficients. So if there are coefficients, remember that's the larger printed number, the number in front of your variable, you divide them. So 10 divided by 2 gives you 5. And they both have a base of y, so we can subtract our powers. 10 minus 4 is 6. So 5y to the 6th. Letter B, negative 25 over 5. I reduce it to negative 5. And then they're both the same base. I subtract my power. 8 minus 4 is 4. Now letter C is tricky. I have 6 over 18. 6 divided by 18 is not 3. You must enter it into the calculator just like it says. 6 divided by 18. I even made a note over here to make sure you're doing that. So that gives you 1 over 3. And then I have x and x, but if you notice, I've got more x's in the bottom. So after I do that subtraction, I just leave it in the bottom and make it positive. So 3 minus 4 is negative 1. I leave it in the bottom because I've got more x's down there, and I just take the absolute value and make it positive. And then example 3 is same concept. I'm just adding, instead of just one variable, now there's 2. But we're doing the same thing. If there's coefficients, divide them. 10 divided by 2 is 5. There was no x's in the denominator, so it stays the same. It stays x squared. And then I have y to the 10th over y to the 4th. Those are the same letters, the same base. I can subtract them. 10 minus 4 is 6. So same letters, I subtract your powers. Same letters, k to the 5th and k, I subtract them to get k to the 4th. X and x, 13 minus 4 gives me 9. And then when you reduce your coefficients, when you divide them, 6 divided by 12. Now the other way around, we do what's printed. 6 divided by 12 gives you a half. So 1 over 2. The other ones are the same thing. They're just different numbers. So when you are dividing with like bases, you subtract your